let's talk about the isosceles triangle theorem and its converse. So let's recall that an isosceles triangle is a triangle that has at least two congruent sides. Okay, so the isosceles triangle theorem says if you have an isosceles triangle, then the angles opposite those sides are also congruent. So the angle opposite this congruent side, or this angle here. Let me get a pen out real quick so I can mark it. So this angle here is congruent to the angle opposite the other congruent side, so here. So in an isosceles triangle, you have two congruent sides and two congruent angles. The converse says that if you start out knowing that you have two congruent angles, that automatically means you will also have two congruent sides. So it goes in the opposite order. The isosceles triangle theorem starts with knowing you have two congruent sides and leads to knowing you have two congruent angles. The converse, which remember to converse is to switch the if and then of a statement, does exactly that. It starts knowing that you have two congruent angles, and then it turns out from that information that you then have two congruent sides. The sides, specifically the sides opposite those angles. Okay, let's talk about, because in some of your questions they will have the names of the parts of an isosceles triangle. So in an isosceles triangle, the congruent sides are called legs. So you have a leg here and a leg here. The non-congruent side is called the base. The angles, so the two congruent angles, those ones at the ends of the base, are called base angles. So this is one of our base angles. And this is our other base angle. The angle that's not congruent, the one at the top up here, is called the vertex angle. So when they talk about the parts of an isosceles triangle, the vertex angle is up here where the legs come together. The base angles are the two that are made congruent by the fact that we have that congruent pair of sides. So let's use that information to solve this. Given triangle GFH is isosceles and vertex angle F. So let's draw that triangle. If I have a triangle here, I don't. I'll have to use lines. Okay, so we know we have an isosceles triangle because it says it's isosceles. It specifically tells me the vertex angle is F. So if these are my congruent sides, F would be up here. Okay, vertex angle is the part that's not a congruent angle. It's where your congruent sides meet. Okay, and it tells me that that angle measures 52 degrees. I'll put that into my picture also. What is the measure of angle H? So here are H and G are down here. What do we know about them? Where, because of the isosceles triangle theorem, we know that if you have congruent sides, the sides opposite those angle are also congruent. So as we label our triangle, we're looking for angle H here. So I'm going to call that X, because that's the unknown value I'm looking for. But the cool thing is, since I know these two angles are congruent, if this one has a measure of X, this one will also have a measure of X. You can't do that on any problem, but when you have an isosceles triangle, you do know these two are the same, and we can go ahead and do that. We can transfer the value from here over to here. My next step is going to deal with the fact that we know in a triangle, all the angles add up to how many degrees? Hopefully you said 180, because that is the case. So we know that if we add our three angles together, so we had an X, and a 52 degree angle, together those should equal 180. And then we just solve from there. So we combine our x's, and an x gives me 2x plus 52 equals 180. I'm going to subtract 52 from both sides. and I get 2x equals 128. And my last step would be to divide both sides by 2. That will give me my measure of x, which gives me not only the measure of angle h, but also the measure of angle g. 128 divided by 2 is 64. So basically, anytime you have an isosceles triangle, so angle h is 64. Anytime you have an isosceles triangle and you know the vertex angle, you're basically saying, well, I know it's a total of 180 degrees. So you subtract this angle out of that, so you know how much is left, and then split the difference between the other two, since you know they're congruent. That's a shortcut that a lot of people take. Okay, so here's another very similar to the last one. Maybe you want to try this on your own. Maybe push pause, try it on your own, see how you do, and then push play to see what answer you came up with. So again, we have triangle GFH with a vertex angle at F. So that's how I know to label the top of my triangle here as F. And I made it a little wider because it said it was 108 degrees. Okay, so then G and H would be my other two angles in the triangle. Now again, I know it's isosceles. This was the vertex angle up here at the top. I know the vertex angle is where the two congruent sides come together. The other thing I know is that in an isosceles triangle, the angles opposite those congruent sides are congruent to one another. So angle H would be congruent to angle G. I'm supposed to find the measure of angle H, which means I need to use an equation of some kind. I need angle H, so I'm going to call it x. And again, I know if H is a measure of x, G is also a measure of x because they are congruent to one another. My next step is to say, well, I know that all together the angles in a triangle equal 180. So I know that my two x's added together plus the 108 degree angle that I know should equal 180. I combine my x's. X plus x gives me 2x plus 108 is 180. I subtract 108 from both sides. That leaves me with 2x equals 72, and I finish by dividing both sides by 2. And I'm left with a measure of 36 degrees. So I know in this triangle, not only angle H, but also angle G are 36 degrees.